think we're going to start. Good morning, everyone. Thanks so much for coming on the last day of the conference, the day after the club night, the morning. So thank you so much. Today we will hear about kind of global efforts to harmonize functional MRI data to kind of identify functional brain abnormalities in behavior and disease. So we'll have two talks about methods for harmonization, for combining all those data sets worldwide. And then we have two talks showing the application of such methods to look at brain abnormalities in depression, as well as a method to identify TMS targets. So I think the presenters will show some of the methods, some of the challenges and opportunities involved in this kind of global data sharing. So I'm sure you just want to hear from the speakers. So without further ado, I'll introduce Jean-Baptiste Poline, who is a professor at Montreal University and will be presenting on behalf of Sebastian Urk, who unfortunately had to go home earlier, but I'm sure JB will do the honors, so I'll invite you up. Thank you.
Yeah, I really wish Seb was here to present that, but he's mostly his work and the work of, actually it's the work of many people in the lab as well. So this is the lab, and this is Seb that should have been here. I've got the hard task to get started on that session, which is just after the club night is something. So yeah, let's wake up. So I will spend a bit of time doing some of the motivation aspects, and then deal with two types of problems that are with this kind of a big consortia, and which is both like finding the data and also actually how do you do standard processing, and then where this may lead in the future. Quick conclusion on that. So one of the motivation really is this very famous paper that you have all seen, I hope. If you haven't, please go and look at that, which is NARP's paper, where if you send the data to like 70 labs, what kind of data, what kind of results do you get, and results. I mean, and depending on who you ask, actually, results. I mean, people say, oh, that's not that bad. If you look at the images, they correlate and so on. But the actual conclusion of the once you threshold those things and what you get in the literature is probably very variable. And like for instance, for that specific contrast, they basically 60% of the 70 labs would, even of the labs actually did something that is quite resembling in terms of T-maps. Even that things like that thresholding aspect, which gets into the literature, is giving you like 40% of yes, this you can reject that hypothesis, or no, you can't. 40%. So it's very variable, and that's one of the issues. So standard preprocessing sounds to be like a good idea, especially for consortium. And that's not only for fMRI. This is a nice paper from which led by Maxime Descotto in Sherbrooke, which shows the variability of the tracks that you get when you analyze the diffusion data, across, again, same sort of a project. And the NARP's paper was I think inspired by that by the NARP's paper. And in the lab, Nikhil, who's in the room somewhere, I can't see because of the lights, was showing that if you take some different segmentation tools and you look at the correlation across brain regions for the different segmentation tools, or identifying volumes, you get very different results as well. Actually, some of these segmentation of structures do find have poor correlation when you look at the correlation across those volumes segmented by different tools. So that analytical flexibility problem is really pervasive, and it's still, I think, not yet well kind of described. I mean, it is more and more described, but how do we deal with it in actual study is not something that is very prevalent yet. There's another problem, which is, when you shift to another population, then, if you learn on the subpopulation here in the UK Biobank, you try to learn if someone is smoking from different variables, and you learn on like a subset of the population, you try to actually, predict to another subset of the population, and you find that the accuracy of that prediction is going down very quickly. So the data set shift or the distribution shift problem is also quite prevalent. So, getting many different population and different data sets is also one of the critical kind of motivation for the tools that I'm going to present. The last thing I want to reiterate, I think everyone knows, but still, it's the sample size problem. So in that specific study, the reason why I'm showing this specific study that was a couple of years ago from the lab is the fact that, if you want power, you really have to have many subjects. And that's, in that study, we had, a small population, clinical population. So what we did was to actually get a very large control population. And how do you get a very large control population? I'm not going to talk about this scanner and all those harmonization problems, but at the moment, you have to find them outside, probably, of your kind of hospital or lab. So that's, some of the tools that I'm going to present will be helpful for that sort of problem as well, finding, across, many different data sets, a control population. So there is, I think, a little bit of a data analysis paradigm shift that is happening. We have like many now, very good and very powerful resources for getting data. This is just some of them, but there's also, but those things are sort of hard to kind of co-analyze. I don't know if you had any PhD student or postdoc, trying to do that. If you are one of those, students trying to co-analyze big data set from different places, you're going to have a hard time. It's not going to be technically easy. That's going to take months, at least, to get that going. There's another aspect, which is, I think, we're more and more, and Enigma is the kind of the flagship sort of example of that. More and more we're going from silo data banks where we analyze one thing to different data sets coming from various groups and in the consortium. So in summary, literature is full of things, but things are a bit hard to know whether that's replicable, and analytical flexibility is probably one of the main factors for that problem. Sample size and data set shift might be also some factors. Silo data sets, I would say siloed, they're sometimes open, but I think they're very poorly interoperable across those big data sets. And I would say that most of the data are still kind of dark data, following the description, which is basically like a lot of the clinical research groups have their data on, and it's a barrier technically, but also legally and ethically to actually, make those data available, or at least findable. So the lab has been embarked into developing, some infrastructures and some open infrastructure with some different perspective than I would say, usually the usual development. So first of all, an emphasis on the good implementation aspect, which is software engineering problems, sustainability. How do you make sure that this is going for a long time? That's not stopping after the grant has ended. But also thinking of the governance of those infrastructure, and especially a distributed governance across all the stakeholders. And with really I think the key message I want to say here is that those tools really should be building blocks of communities. And that's what I'd like to push and think about is those standardization and tooling aspect is really creating communities of practices and communities of training and so on. So, what's the time? Oh, 7 minutes, that's okay. I think motivation is really important, so I'm glad I'm spending a bit of time on that. So finding data. So Seb in particular, but also with the team, so Seb is here, again, think of me as him at the moment, has been developing this Neurobagel framework, which is basically going from the centralized paradigm with a large centralized where all data have to move in one place, and there's a kind of a centralized ethical and legal framework to that, with some issues of maintenance aspects, sustainability aspects, changes are very hard on those infrastructure and so on, to moving to paradigm shift, which is a distributed infrastructure where the data stay local, the ethical and legal framework may be different across the data sets and across the institutions, and that means that we have to base our things on standards. So harmonization of terminology and what variable is very hard. If you take the example of Open Neuro has thousands of data sets, but if you look at all those variables that are in this description of the data set, they're not always harmonized at all. So that's very hard to actually co-analyze those things. So the Neurobagel has done is to actually create some very simple interfaces to say, hey, if I have dx in that column here on site 1, but I have group on site 2, I have a way to actually say, okay, that's actually the same thing that I'm talking about, and there's a nice, really, really cool interfaces to actually very simply create those things, and that's an example of that interface where you take all those clinical and assessment variables and you actually map to standards, kind of ontology and terminology through a web-based interface which needs no installation and is very kind of easy for a clinician to actually to do. And that creates a very simple, I mean, don't look at the technical aspect there, but what I want to say is that it creates a very simple data dictionary that is a bit compliant thing that's, just you're adding a layer of interoperability to your data set very simply. So now we can actually query across many sites that have those data dictionary. I want to take the example of the Enigma PD data sets, where Enigma PD has been working with us for some time now, and we can actually now search across different data sets in Enigma PD, and that's what data do you have that have that kind of demographics, but also have an assessment. This assessment also have this kind of modalities in imaging, and maybe have been processed with this specific pipeline. I'll skip that for the sake of time, but this is a successful project now. Even Open Neuro is actually using Neurobagel to actually to query things in a harmonized way to get cohort across many data sets. And the second project that I want to talk about briefly now is okay, we talked about finding data and finding possibly processed data. Now, how do we process that in a standard manner locally, because we don't want to actually process in GDPR, for instance, you can't actually move the data to the US Amazon-based things. So Nipoppy and Nikhil has been spearheading that. Where is he? He's gone somewhere in the lab. Is a kind of a protocol that you establish in the lab and you establish in your institution. It's a dry lab protocol in some ways. It's based on standards like beads and it actually extends the standards of beads in some ways, and we are merging now to make that the bead standards. And it's also like a PIP and syllable package and a training environment for people that want to know how do I go from the raw data to my imaging derived phenotypes. It's also a community now. So it goes from the capture of data to the organization to the processing with standard processing with containerized pipelines, such that you know exactly what's what is happening with the right environment, but also with the exact inputs. So it has the boutique framework is really wrapping things in a way that is that the provenance of the thing that you've put computing is really well done. And it is extending bits in a way, there are many sort of processing, I would say, platforms, and with whom we're working with. So, for instance, we had 3 days of hackathon with, in particular, with Neurodesk, which is a fantastic platform, and that now we can integrate Nipoppy with Neurodesk as well. But those platforms are more centered on actually processing things. We are more centered in describing the whole study level processing aspect. So going where do you put your raw data? Where do you put the diacoms? How do you reorganize the diacoms? How do you bitsify things? How do you all those things that are kind of, where are the containers that have been launched on this, on the data? Where do you put the derived data? How do you track and show like what's going on? How do you put, you know, QC aspect? So all those kind of study level that are not specifically bits data set level, sort of a specific, like, you know, standard, that's the thing that we're trying to kind of express in this package. So the tracking, for instance, is telling you, okay, now that you have launched that container on those things, how many of those subjects, you know, data have been actually processed, and how many have failed, and what do I need to relaunch, and so on. And if a new subjects are, you know, come in the study, and how could you relaunch everything automatically? So it's a helper tool on, you know, like, but a very flexible one, not not an integrated kind of platform. And then how do you extract IDPs, you know, for the study that you want to do? So this is, again, a specification, a tool, and really merging with the BEADS project in the future, in the near future. So this is a modular ecosystem. I like to show that those two things, the finding the data and the local processing, they interact quite a lot. For instance, in particular, you know, finding processed data is really important to us because there's so much, you know, time and resources and carbon spent on like a reprocessing, like, you know, those data sets. So this is how you can actually now query on the processing and across all those processed data in this example with the Nipopp. I would like, again, to re-emphasize this is like a community sort of effort. We now have like many labs interested in co-developing this with us, as well as, you know, standard organization. So all those things are based on standard. If you really want to have the same sort of infrastructure installed and played at different sites, well, I mean, you have to use standards, and that's what we're trying to build. Not only the standards, but the community around those standards. And these are at least some of the communities and standards that we're working with, in particular maybe the NCF, the NIDM, the W3C, of course, like, but BEADS is one of clearly the one thing, but DataLab as well, and so on. Where this is going and what do we want to do in the future and what we're actually starting to do now, right now, is, and this is an abstract by early work by Michel Wang in the lab. Basically, we want to use those infrastructure to actually do some federated learning. So we think that more and more it's going to be it's going to be difficult to move data for different reasons. And more we will need to actually learn from different data sets that are locally, that are, you know, placed in all over the world. So I think that's, that early work is showing you across, you know, different data sets that are not in the same place, how you actually learn, you know, progression of cognitive decline, or you learn how, you know, diagnosis, or you learn age, or you learn something from the data, but across all those data sets. So we're partnering with some like IT aspect with, you know, with FedBiomed, for instance, to do those sort of things. But I think that's a direction. I mean, there was only like, you know, 4 or 5 abstracts to this conference on federated learning aspects, you know, but I believe that, you know, in Bordeaux there will be many more, because that's a trend that is an important trend for the community to, you know, do those things. It's technically challenging, but also like, but it helps with the social aspect of science. It also means that we have to build those communities and those consortium and those working groups. Take-home message, so again, building communities of standards, I think is critical. We want to be cheap and sustainable. We want to avoid the lock-in issue, so that if you adopt those things, you are very free to get out of those things, which is not always an easy thing. So transparent distributed governance for distributed infrastructure and ecosystem is one of the kind of a motto. And we work with the incentive and the thing that we love to do, the things that we get recognition for, possibly the funds and the aspect, and the rules that are, you know, like ethical or legal rules, or like, you know, grant agencies rules. Those things are the things that we work with to get our communities going on. This is a quote from Carol Goebel that loves to put these things in there. But I think it's important to work with those incentives to you know, to build those communities and communities of practice and standards. And thank you very much.
Thanks, JB. Fantastic overview of the methods, and I think as a community we're so lucky that you and your team put so much effort and time into developing these methods that we all benefit from. So we have time for 1 or 2 questions. I have one question online, but also feel free if you have a question from here to go to one of the microphones and ask a question. But JP, we have a question online. If a lab implements Nipoppy or Neurobagel, what's the maintenance efforts associated with it, and how easy is it to set up?
So really, Neurobagel in particular has been designed to have very, very low maintenance effort and also low installation effort. At some stage, when you have to be visible on the internet, you have to have a little bit of an IT thing. What the team of Seb's team has done is really to minimize that thing. So we have now many people that have, really many examples that said, okay, I'm going to look at it. For instance, actually the Neurodex people here in Australia, they, at the hackathon, they look at it, and and then a couple of hours later say, okay, we have a node, we have now data available and searchable across things. So I think that effort has been done, and the maintenance aspect is really on the same thing. And again, if you lose that infrastructure, you don't lose anything. You have a nice dictionary that is machine readable, and that's all what so I think that's an important aspect. You don't actually install a large database that will need maintenance and will need someone to be paid for maintaining and so on. So I think there's a little bit of maintenance, but there will be updates, and there will be how to update those little graph stores and things like that. But really, that aspect is one of the things that we've been working very hard on. For Nipoppy is more like a processing environment. The thing that makes it more maintainable and I think more useful as a community level is that it's now kind of spreading across many labs, and there's a Discord channel, there's community-based questions and answers. The same kind of a framework can be reused by the next PhD student or the next postdoc, or and so having that kind of as a standard is a bit like beats. Does beats require maintenance? Yes, it does in some sense, but it's a community-based maintenance of a standard rather than your own infrastructure maintenance that you've created and things like that. So I think that's the angle that I'm trying to make, is that if you work on standards as a community, if the governance of those things is distributed as well, then we are in a much better and more efficient as a community in working on those things. So I think that's the efficiency aspect I haven't emphasized, but I think it's a much more efficient way of working than we used to.
Great, thank you so much.